At this point in this unit, ancient Greek and now Roman astronomy has gotten quite sophisticated. For example, using the idea of the celestial sphere, we could explain the following phenomena. We could explain the daily or diurnal motion of the sun and stars over the course of the day. We could explain the motion of the sun along the ecliptic, thereby, for example, describing the seasons. We could also, for example, explain the lunar phases as the moon orbits the Earth. We also understand eclipses at this point, and by the time of Ptolemy, we have now measured accurately the distance from the Earth to the moon. So by this point in time, ancient Greek and now Roman astronomy has gotten pretty sophisticated. However, other than the stars, the sun, and the moon, what other groups of objects up in the sky have we not yet discussed? And that's the planets. This is where it all falls apart for the ancient Greeks. First of all, the word planet. The word planet is an ancient Greek word for wanderer. So when we're talking about the planets, we're talking about the wanderers. The ancient Greeks attempted to incorporate the motions of the planets into their geocentric or Earth-centered universe, their geocentric cosmology. They made a couple of assumptions in doing so. First of all, they assumed that all celestial motion, not just involving the planets, but involving the sun, for example, and the moon, they assumed that all celestial motion was perfectly circular and centered on the Earth. For whatever reason, the ancient Greeks latched onto this idea that the circle represented some sort of perfect geometry. And so then therefore, in their minds, because the heavens were perfect, this then meant that all motion in the heavens had to be perfect as well. They also made the following assumption. They assumed that the closer a planet or an object is to the Earth, the faster it moves against the more distant background stars. If you make those two assumptions, then the following picture emerges. This picture is known as the Aristotelian Universe. It's named after the philosopher of Aristotle, who popularized the idea. So first of all, the assumptions that I just mentioned. So these are assumptions according to the ancient Greeks. First of all, one, all celestial motion is perfectly circular and centered upon the Earth. Okay, and then secondly, the closer an object is to us, the more faster it moves against the distant background stars. The closer an object to the Earth, the faster the object moves. Against the more distant background. Once again, if you make these assumptions, the following picture emerges, what's called the Aristotelian Universe. Okay, so first of all, we have the Earth at the center of the universe. Remember that this is what it looks like when we stand on the Earth and look out into the universe. It looks as if the Earth is at the center of the universe and the universe is an enormous sphere. Remember that the ancient Greeks took this literally. Okay, so we have the Earth here at the center of the universe. Okay, and then the object that is closest to us, because it moves the fastest against the more distant background stars, is the moon. All right, so right here is a circle to represent the moon's orbit about the Earth. Remember that all celestial motion is perfectly circular and centered on the Earth, according to the ancient Greeks. The next fastest object to move against the background is the planet Mercury. And then after that is Venus. Okay, and then after that, moving along the ecliptic against the distant background stars is the sun. So here's the sun. Obviously, I'm running out of room now to completely draw these circles. But then after the sun, we have the other three planets that have been known since the time of antiquity, before the invention of the telescope. That's Mars, Jupiter, and Saturn. And Saturn. Like so. Once again, if you make the assumptions that I've written on the top board, this picture emerges. Now, there are two major problems associated with this picture. These problems are observational facts. In other words, if you take the time to observe the motion of the planets, these observational facts are inescapable. These are the following. Okay, so there are two problems. These problems are observational facts. Two problems with this model. Okay, the first of those problems concerns the planets Mercury and Venus. It is a fact that you will never see Mercury or Venus in the middle of the night. You will only see those two planets near twilight, that is around sunrise and around sunset. So Mercury and Venus are only visible during twilight hours, near sunrise and sunset, never in the middle of the night. So notice how the Aristotelian universe cannot explain that fact. For example, according to the Aristotelian universe, the following can happen. Let's say, for example, that the sun happens to be right here in its orbit around the Earth. And at the exact same time, let's say that the planet Mercury in its orbit around the Earth happens to be right here. Notice it's in the opposite direction of the sun as seen from the Earth. So then therefore, if you're standing on the Earth here, you should be able to see Mercury when it's here in this position. You would be looking in this direction, and the time of day, your location, for example, could be midnight. Obviously, this observational fact cannot be explained by this model. It is a fact that Mercury and Venus are only visible during twilight hours. And then secondly, and perhaps most damning of all, what is called retrograde motion. All of the planets do this, what I'm about to describe, but it's most noticeable with the planet Mars. It's visible to the naked eye with respect to the planet Mars if you're watching carefully. And believe me, the ancient Greeks were. Approximately once every 2 years in the case of Mars, over the course of a couple of weeks, its behavior in the sky is rather strange. Let's say that you watch Mars, for example, night after night. And as you do, you note its position with respect to the more distant background stars. If you do, you will then begin to see the following. You'll watch night after night and the position of Mars changes in the sky relative to the background stars from one night to the next. And then all of a sudden, Mars will appear to slow down, turn around and move in the opposite direction, slow down again, and then keep going in its original direction of motion. It literally makes a little loop in the sky like so, approximately once every 2 years over the course of a couple of weeks. It basically looks something like this. Okay, so let's say right here in the background stars, like so. And then here's the planet Mars moving along against the more distant background. And then it literally does this, like so. Makes a little loop in the sky like this, where it takes this loop, it does so over the course of a couple of weeks. It's unmistakable in the case of Mars. It's obvious if you're watching, and the ancient Greeks were. All the planets do this, but it's most noticeable with the planet Mars. Obviously, the Aristotelian universe fails to explain this observational fact. So then, therefore, what did the ancient Greeks do about these problems? They literally chose to ignore the problems and hope that they would go away. They didn't go away. Okay, let me go ahead and pause here as part one of this opening lecture on the planets.